so today we're going to look at an introduction to fractions. A lot of this you have seen. It's a review, but we're going to build off of that through the year. So we just want to go through things to make sure that you remember everything. Just looking at fractions, I've got the figure right here. Notice it's been divided into 3 boxes. I have 2 of the boxes are shaded and 1 of them's not. And so if we want to write this using mathematical symbols, we would say that blank of the figure is shaded, and in fact 2/3 of the figure is shaded, or blank of the figure is not shaded, and in fact 1 out of the 3 is not shaded. The symbols 2/3 and 1/3 are called fractions. There we go. So nothing really new. Given the fraction 2/3, what is the denominator of the fraction? The denominator is the bottom number, and therefore the denominator is 3. What is the numerator of the fraction? And the numerator is the top number, and that would be 2. Sorry for the typos there. So if we're looking at these 2 following figures, notice that there are 6 pieces here, and 4 are shaded. There we go. So we can write this in a fraction as 4 over 6, or 4 out of 6. And in fact, we can simplify this. Notice that both the top and the bottom are divisible by 2, and therefore we can reduce this, and if we divide 4 by 2, we get 2. If we divide 6 by 2, we get 3. These are equivalent. This piece is in the simplest form, and this piece here is not. Alright, what about the next one? So I have 9 pieces in total, and 6 of the pieces are shaded. So I would say 6 out of 9, or 6 over 9. And again, we always want to leave our fractions in the simplest form. And notice that both 6 and 9 are divisible by 3. And therefore, I can simplify this by saying 6 divided by 3 is 2, and 9 divided by 3 is also 3. So this side here is the most simplified. It is equal to 6 over 9. It's just that 6 over 9 has not been simplified yet. What do you notice about all the figures above? Are there any similarities? Well, yes. They can be simplified to be the same. And we call these equivalent fractions. Alright, well, let's simplify something that's a little bit more challenging. So the fraction here is 24 divided by 36. So we want to simplify it to lowest terms. Okay, so I start off with 24 over 36. And we're going to use our divisibility rules. Okay, so we looked at that last unit. And what I notice right away is that 24 and 36 are divisible by 2. So I can reduce this by saying, okay, well 24 and 36 are divisible by 2. 24 divided by 2 is 12, and 36 divided by 2 is 18. There are other numbers that you might have seen right away, and as long as they're both divisible by the same number, you can reduce by that number right away. It doesn't have to be 2. I'm going to ask myself, is this in lowest terms yet? And the answer is no. Notice that 12 and 18 are again divisible, oops, forgot the other, by 2. So I can rewrite 12 over 18. 12 divided by 2 is 6. 18 divided by 2 is 9. So we have to ask ourselves again, is this in the most reduced form? And in fact, it's not. Notice that 6 and 9 are divisible by 3. So I can write 6 over 9, 6 divided by 3 is 2, 9 divided by 3 is 3. And finally, I'm going to ask myself again, are they in simplest forms? Well, yes, in fact they are, because 2 and 3 are prime, and they're not the same number, and therefore 2 over 3 is simplest form. Or we say lowest terms. So we say that 2 over 3 is in simplest forms. Okay, so we also like to compare fractions, okay? And we use these two symbols, less than or greater than, to represent that. Now, I always try and remember this by, we read left to right. When I read left to right, look, I get to the littlest part of the symbol first. This is telling me that I have a less than symbol. The one over here, notice that as I read left to right, like we normally do in North America, I get to the big part of the symbol first. And this symbol is the greater than symbol. Alright, so if we want to compare these, the first thing we're going to do is list some equivalent fractions. So step 1, list some equivalent fraction. So I'm going to start with 3/4, or 3/4. And my first one is just 3/4. These are multiples, by the way. So from last unit, if you were thinking about, these are still multiples. If I multiply the top and the bottom by 2, I get 6 over 8. And then I would get and if I multiply the top and the bottom of 3/4 by 3, I get 9 over 12. If I multiply the top and the bottom by 4 of 3/4, I get 12 over 16. And if I multiply the top and the bottom of 3/4 by 5, I get 15 over 20. And if I multiply the top and the bottom by 6, I get 18 over 24. I'm going to stop there. We can keep going and keep writing multiples. As you know, there's an infinite number. But we'll just stop there for now. In blue, I'll do the 4/5. So same idea. The first one would be 4/5. Okay, if I multiply the top and the bottom by 2, I get 8/10. If I multiply the top and the bottom by 3, I'll get 12/15. And if I multiply the top and the bottom by 4, I get 16 over 20. If I do one more, I get 20 over 25. Now, again, we can keep going, but I'm going to stop here because what I noticed is that here I have the denominator of 20, and here I have the denominator of 20. So I can now use these two fractions and compare them. So step 2, we listed some equivalent fractions for 4/5. Step 3, find two equations where both have the same denominator. Well, those are what's circled in the green, so I can say that 3/4 is equal to 15/20. And I can say that 4/5 is equivalent to 16/20. And now I have to decide which one is the bigger one. Well, 16 out of 20 is a lot bigger than 15 out of 20. So using my symbols, I would say 16 out of 20 is bigger than 15 out of 20. And if I go back to the most reduced or simplified form of the fraction, remember that 16/20 is just 4/5. And we use the same symbol because we've already proved that 4/5 is greater than 3/4. And this would be our solution. And I've used the greater than symbol. Remember, when we read left to right, just as we normally read, I get to the bigger part of the symbol first. Alright, let's look at some improper fractions. Looking at the above figures, we see that each shaded square can be written as a fraction. Now notice that here I have this whole piece is shaded in, but only one out of 1, 2, 3 has been shaded in. And therefore we can say that I have 1 and 1/3 shaded, which means the total number of shaded boxes 1 and 1/3. Okay, we can represent this by 1 and 1/3 or 4/3. Okay, 4/3, I'm just going to write it on the side so I can write it like that, is an improper fraction where 1 and 1/3 is our mixed number. And numbers written where the numerator is smaller than the denominator, so remember, so it's numerator and denominators on the bottom. Okay, so number written where the numerator is smaller than the denominator is called a proper fraction. And some examples, so just 1/2, 3/4, 11/12. Those would all be examples of proper fractions. Okay, so for example 3, all I've done is I've drawn in 5 apples, and that's because the question says there are 4 people and there are 5 apples. Using fractions, divide up the apples evenly amongst people. How many will each person get? So I'm going to choose just a few names from our class. So we have Marco, oops, there we go, Bryn, Wesley, and Phoebe. Now, notice that I can give Marco a full one, Bryn a full one, Wesley a full one, Phoebe a full one, and then everyone has to share the last one. Therefore, each person will get 1 apple and 1/3. We can write this as 1 plus 1/3, or as an improper fraction as 1/3, or as a mixed number as 1/3, and as an improper fraction as 4/3. Okay, so example 5, I want to rewrite 33/5 as a mixed number. So what I can do is I can use my long division. So I have 33, and I'm dividing 33 by 5. Well, the closest that 5 goes into 33 is 30, and that happens 6 times, and I have 3 left over. What this is saying is I have 6, or 5 can go into 33 6 times, and I have 3/5 left over. And that's our mixed number. So what about if I want to go the other way? What if I want to go from 12 and 4/5 to an improper form? So when you read 12 and 4/5, this also reads as 12 and 4/5, and the and is implying addition, 12 and 4/5. Well, we do know how to add fractions, so we need a common denominator. Okay, 12 is the same thing as 12/1, and therefore my common denominator would be 5. So 12 times 5, so I'm going to rewrite this as 12/1. I'm going to multiply the top and the bottom by 5, and then I'm going to add it to 4/5. Well, 12 times 5 is 60/5, and I'm going to add it to 4/5, which is just 64/5. And this is my improper fraction. And we're done, so you can start the homework assignment now.